Hello everyone. In today's session, we are solving seventh problem on module 1, drawing the reactance diagram from the one line diagram. So this is a given problem as you can see here. So draw the per unit reactance diagram by considering 20 MVA and 6.6 kilovolt in a generator one circuit. So this will be your base value. So you have to consider this value as a reference value of the generator 1 circuit. The rating of the remaining components as given here. The generator 1 is having the rating of 10 MVA, 6.6 kilovolt, and the reactance is given as a 10%. Converting that into a per unit, you'll get 0.1 per unit. Then generator 2 is having the rating as 20 MVA, 11.5 kilovolt, and the reactance is 0.1 per unit. So now we'll write the ratings of all the components below the single line diagram. The ratings of all the components it is written below the single line diagram itself. So here the transformer T2, it is not a 3-phase transformer, it is a 3 single phase transformer, and the rating is given here. 7.5 will be the low voltage rating and 75 will be the high voltage rating. So here you need to convert the 3 single phase into a 3-phase transformer. How do you convert? Means multiplying 75, the higher voltage rating should be multiplied with root 3. So now after multiplying 75 with the root 3, we'll get 115. So now we can write the rating of the T2 transformer is 130 kilovolt slash 7.5 kilovolt. So this is the rating of the transformer T2. So the same I'll write here, 130 kilovolt slash 7.5 kilovolt. So even this is the MVA rating for a single transformer. Convert this for a 3-phase transformer, multiplying 10 into 3. So you'll get 30 MVA and the reactance will be 0.1 per unit. So now after this, proceed with the step. So we have five transmission lines are given here with the different ratings. So all these ratings are given in ohms. Convert this ohmic value into per unit value. Now proceeding with the step 1, that is choosing a base power for the entire system. So in the given problem itself, they have mentioned 20 MVA will be the base power from the generator 1 circuit and 6.6 kilovolt will be the base voltage of the generator 1. So same I'll write in the step 1 and step 2. So MVA base new, that is equal to 20 MVA. Then step 2 will be kilovolt base new of generator 1 will be equal to 6.6 kilovolt. So this will be your reference or the base value. So by taking this value, you need to calculate the base voltage of the remaining components. So which and all the components will calculate the base voltage means all the transmission lines, then the generator 2. So transmission lines will be coming on the HT section. First write the HT formula, later we'll calculate the kilovolt base new for all the transmission lines. So there are 5 transmission line reactances are there. All the 5 will be having the same base voltage here. So now first I'll write the formula. Use this formula for calculation of all the reactance of the transmission line. So that is, we can rewrite the formula kilovolt base new for the transmission line. So what all the transmission line this base voltage will apply means for the 100 ohm, for the J75 ohm, similarly for the 20 ohm, J20 ohm, then for the 50 ohm and for the J150 ohm. Use this formula now. Kilovolt base new on the LT section. LT section is nothing but the generator section, which will be a reference value 6.6 multiplied by the rating of the transformer. So now look at the single line diagram. So between the generator 1 and all this transmission line, we have T1 transformer is there. So that high voltage rating is 115 and the low voltage rating will be 6.6 kilovolt. So that we can write the rating of all this transmission line will be having a base voltage as 115 kilovolts. So next calculate what will be the base new value of the generator 2 by using LT section formula. So this is the formula. Kilovolt base new on HT nothing but it is always the transmission line. So all the transmission line having the base voltage as 115 kilovolt multiplied by low voltage by high voltage. So taking the transmission line as a reference, we are calculating generator 2 base voltage. So T2 transformer is coming in between the transmission line and generator 2. So here the low voltage is 7.5 kilovolt and the high voltage will be 130 kilovolt. So after multiplying, we'll get the base new value for the generator 2 will be 6.6 kilovolt it is. So this completes step 2. So next we'll proceed with the step 3, that is calculation of per unit reactance for all the 5 transmission lines. So this is the formula for converting ohmic value into per unit value. Now look at the given single line diagram. So here we have 5 transmission lines are there. For all the ohmic value we need to convert into per unit. So first we'll proceed with the J100 ohm transmission line. So here X in ohm will be equal to J100 multiplied by MVA base new. MVA base new means you have to see the step 1 value, that is a 20 MVA. Then divided by kilovolt base square new of the transmission line. So that means, so for all the transmission line we are having the base voltage as 115 kilovolt. So now use this formula and substitute. We'll get the answer for the 100 ohm transmission line as J 0.15 per unit it is. So next similarly we'll do it for the remaining 4 transmission line reactance by converting ohms into per unit. So now we can observe in the same manner how I calculated for 100 ohm. Similarly I calculated for all the 4 reactances. So here this only X in ohm value will be changes. This MVA base new and the kilovolt base square new will remains the same for all the transmission line, because all the transmission line is having a base voltage of 115 and MVA base new will be the same for all the components in the given single line diagram. So this is the answer for all the transmission line reactances. So this completes the step 3. Now proceeding with the step 4, that is a per unit reactance calculation for all the components in a given single line diagram excluding the transmission line. So first we'll calculate the per unit reactance for the generator 1. We know the formula for the per unit reactance for generator 1 new, that is X in ohm, X old value, reactance old value multiplied by MVA base new divided by MVA base old into kilovolt base square old by kilovolt base square new. So this is the common formula for all the reactance calculation in step 4. So now first we'll do it for X old value in per unit for generator 1. So now look at the given data here. So this is the generator 1 which is having the old value of X is given as 0.1 per unit, 0.1 multiplied by MVA base new. So that is step 1 value, it is 20 divided by MVA base old. Old means a given value, it is 10 MVA multiplied by kilovolt base square old. Old is 6.6 kilovolt and new means it is the step 1 value, that is also 6.6 kilovolt. So after dividing this, we'll get the value for the generator 1 as J 0.2 per unit. So next similarly using the same formula, I'll calculate the per unit reactance for the generator 2. The per unit reactance for the generator 2. So X per unit new for generator 2 will be equal to X per unit old, means the given data for generator 2 is 0.1 only multiplied by MVA base new means it remains the same 20 MVA divided by MVA base old. Old is the given value in the problem, it is also 20 multiplied by the kilovolt base square old. Old means 11.5 kilovolt it is divided by kilovolt base square new. So now for the generator 2 we have the rating as 6.6, that is the new value. So now divide this, we'll get the answer for the per unit reactance for the generator 2 as J 0.3 per unit. So after completing with the generator 1 and 2, the remaining component is transformer 1 and transformer 2. So same formula I have written even for the transformer 1 also. X per unit volt for the transformer 1 is 0.15 per unit it is, multiplied by MVA base new, that is step 1 value 20, divided by MVA base volt. Volt means the given value in the problem. It is 10 MVA, multiplied by kilovolt base square volt by kilovolt base square new. So for this we have to cross check in the given single line diagram itself for the primary as well as for the secondary side. So now look at 6.6 kilovolt is the volt value. So for the primary I am substituting here, and this has been connected to generator. The new value of the generator is 6.6 kilovolt only. So that will get the answer for the primary side as 1. Similarly, cross check for the secondary. 115 kilovolt is the volt value given in the problem, and this secondary side of the transformer is connected to transmission line. All the transmission line having the same reactance, same base voltage as 115. So on either side if you consider means you will getting the same answer as 1. So now we can consider any of the side, primary or the secondary, because both getting the same answer. I'll consider the secondary 115 whole square. So we'll get the answer for the transformer 1 as it is 0.3 per unit, that is J 0.3 per unit. So the last component it is left is the transformer 2, that I'll do here. Now doing for the T2 transformer, X per unit volt value given in the problem is for the T2 transformer it is 0.1, multiplied by MVA base new, it is 20 MVA, divided by MVA base volt as 30 MVA, multiplied by kilovolt base square new. New means kilovolt base square volt divided by kilovolt base square new. So we can compare for the primary side as well as the secondary side. Kilovolt base square volt means the given value, it is 130, and it has been connected to the transmission line, that is 115, the new value. So after substituting you'll get the answer as 1.1, and similarly we'll cross check for the secondary side. 7.5 is the kilovolt base volt value, and this has been connected to generator. The new value of the generator is 6.6 kilovolt. Even substituting for the secondary side also you'll get the answer as 1.1. So either side if you consider you are getting the same answer. So any one side you can consider 130. I am considering on the primary side 115 whole square. So I'll get the answer for the transformer T2 as J 0.08 per unit it is. So this completes step 4. The final step is converting the given single line diagram into a reactance diagram. So observe here the generator 1, that can be written as in this way. This is the reactance diagram for the generator 1. This is reactance Xg1 and this is the source voltage Eg1. Generator 1 is connected to the transformer T1, that is having the reactance as here. This is Xt1 and it has been connected to a common bus bar, that is A, and this bus bar A is connected even to the C bus bar. In the same way we will represent. So first I'll represent the transmission line reactance for the J100 ohm. So this is the reactance for the transmission line 100 ohm, and after that the same A point or the A bus bar, it has been connected to J75 ohm transmission line. So this is the reactance for the J75 ohm transmission line, and after that this B or the bus bar B, it is connected to J50 ohm transmission line. So that will represent here. So this is the reactance for the J50 ohm transmission line, and after that the from bus bar C to bus bar D we have a J150 ohm transmission line is there. So that we will represent here. This is the reactance for the transmission line J 150 ohm, and in between the bus bar B and bus bar C one more transmission line is running, that is J 20 ohm, that I'll write here in between this. So this is the transmission line reactance for J 20 ohm, and after that to the bus bar D we have transmode T2 and G2 is connected, that is this is the bus bar D point. So here will represent the transmode T2, this is the reactance for transmode T2, and then we will represent the generator G2. So this is the reactance for generator G2 and this will be the source voltage G2. So this is how you have to represent the given single line diagram into a reactance diagram. So this will be the reference bus. So after that, don't forget to write the reactance of all the components which you have calculated in step 2. So step 3 and step 4. That completes the given problem. Thank you.